Did you know you can create a Swift interface for Xcode, or that Xcode now supports AI agents? Meanwhile, parameterized tests can quietly ruin your code. Hi there, this is Mermaid, your monthly digest on iOS and macOS world. I'm Mermaid, an engineer at Clean My Mac. And let's get started. Apple has officially released Xcode 26.3, bringing a major update to the development environment by introducing agentic coding. The update allows developers to integrate AI agents such as Anthropic Claude and OpenAI's codecs directly into Xcode. Instead of offering simple autocomplete suggestions, these agents can interpret broader goals, plan multiple tasks, and interact with project files and tools inside the IDE. With the new capabilities, agents can navigate codebase, modify files, run builds, identify errors, and propose fixes with far less manual input. Xcode 26.3 also adds support for the Model Context Protocol, MCP for short, an open standard designed to improve interoperability between AI models and development tools. The community has already reverse-engineered Xcode's prompts and instructions to better understand how Apple's AI assistant's coding works. One interesting thing: Apple instructs AI not to use combine. Instead, it recommends Swift's async await and actors as the preferred concurrency approach. I'm personally a bit surprised Apple shipped this update now, rather than announcing it during WWDC. Xcode's traditional release has been lagging behind modern AI advancement, and this move suggests Apple is trying to close this gap. We've already tried this update, and the agent inside the Xcode feels and works like any other agent. The experience reminded me of Cursor, the same sidebar with agent chat, multiple conversation, and file referencing. One thing I noticed is that Xcode's agents tend to ask more questions about your intent and frequently request permissions to modify files. Also, the agents integrated into Xcode don't always appear to run the latest versions. For example, Xcode 26.4 Beta 1 includes Codex 0.87, while the current public release is already at 0.101. But my personal highlight of this release is the ability to connect Xcode as an MCP server to any agents on your Mac. Once connected, agents gain access to structured project information, file hierarchies, source code, build settings, diagnostic, compiler errors, run or test workflows, and more. In total, Xcode provides 20 tools. By offering this level of integration through an open protocol, Apple enables third-party agents to operate inside the IDE with a much deeper understanding of the developer's workplace. A recent Swiftology article by Alex Ozen highlights several practical pitfalls that developers are seeing with parameterized tests in Swift testing. It sheds light on limitations that aren't obvious at first glance. Parameterized tests are one of the most promoted features of Apple's Swift testing framework, introduced at WWDC 24. They let you define a single test function that runs over a collection of inputs, cutting down repetitive boilerplate and making tests more concise. However, as team adopts Swift testing at scale, this pattern can create gaps in test coverage when the assertion depends on the same computed values used in the code under the test. In those cases, bugs that would be caught by individual test cases can slip through. The article also notes that embedding logic inside tests that mirrors implementation detail can make tests fragile and harder to maintain as the code evolves. Another challenge arises when working with collections, such as enum. Relying on case-iterable and auto-generated lists can introduce subtle failures if case order changes or if expected output collections don't match the input sizes. In such situations, some test cases may effectively disappear without a clear signal. This fragility reflects a tension between test conciseness and clarity or precision in expected outcomes. The author suggests pairing inputs and outputs rather than depending on generic constructors like zip. A new open-source project, Beautiful Mermaid Swift, aims to bring native Mermaid rendering to Apple platforms without relying on WebView or embedded JavaScript engines. Developed by Lucky Labs and distributed via Swift Package Manager, the library parses Mermaid syntax and renders diagrams into native UI or NS image objects, making it a good fit for iOS and macOS applications. Unlike many existing approaches that simply wrap a web-based Mermaid renderer, Beautiful Mermaid Swift implements a pure Swift rendering pipeline, inspired by the popular Beautiful Mermaid project. It supports major diagram types, including flowcharts, sequence, stats, class, and entity relationship. The library also ships with 15 built-in visual themes, such as Dracula, Nord, and Tekia Knight, plus a minimalist mono mode for clean two-color out. By removing the need for JavaScript bridges or WebKit dependencies, the project unlocks possibilities for generating documentation visuals, developer tools, education apps, and internal dashboards fully within the Swift ecosystem. As diagram-driven workflows continue to grow in popularity, native solutions like this could make Mermaid a more seamless part of Apple platform development. The Swift project has published a new update focused on improving the usability of C libraries in Swift, addressing long-standing friction for developers who bridge between Swift and existing C APIs. Historically, Swift's interoperability with C has required boilerplate and manual tweaks to bring C constructs into Swift's more expressive type system, especially around pointer handling, memory management, enums, and opaque types. The latest effort from the Swift team aims to reduce these pain points by evolving how C APIs are implemented and represented in Swift, making them feel more Swift-like, without sacrificing performance or safety. Key improvements include refined importer heuristics that better translate common C patterns into safer Swift interfaces, along with enhancements that maintain clarity around ownership and pointer semantics. The goal is to balance between Swift safety guarantees and the flexibility needed when interacting with low-level libraries. Early examples shows how common C idioms, such as functions returning pointers or using opaque context, can now be represented with less ceremony and more idiomatic Swift code. This update also reflects community feedback and real-world use cases, including developers working with networking stacks, system APIs, and legacy C code bases migrating to Swift. By smoothing the interop surface, the Swift project hopes to make it easier to developers to leverage the rich ecosystem in existing C libraries while writing idiomatic Swift. That's all news for today. Would you use agents in Xcode? Tell us in the comments, and see you.